Welcome back to the deep dive. Today we are tackling something, well, really ambitious. It's a framework in theoretical physics called Casimir-Coupled tachyonic venting.
Which thankfully we could just call CCTV.
Yes, much better. And CCTV isn't just theory, it's actually proposing a way to solve maybe the two biggest paradoxes in physics right now.
It really is a remarkable piece of work, mostly because it suggests we don't need to throw out fundamental principles like causality or quantum mechanics to figure out black holes.
We just need a different perspective.
Exactly. A different way of looking at things like speed and information.
Okay, so our mission for this deep dive is to really get clear on the core claim of CCTV, which is that you can have faster than light phenomena, but only inside a specific quantum channel, and crucially, without messing up causality or losing information.
Right, and that tackles the two old headaches, as you call them. First, this idea that absolutely nothing can go faster than light, FTL.
Full stop.
The universal speed limit.
And second, the black hole information paradox. This huge problem where it seems like black holes just delete information when they evaporate.
Which quantum mechanics says is impossible. Information can't just vanish.
Precisely. It violates unitarity, a sacred law.
So CCTV comes along with this.
Yeah.
Well, it sounds almost too neat, this four-part mantra. FTL in the channel, causal in spacetime, information preserved, entropy obeyed.
Yep, that's the tagline.
But how on earth can those first two bits coexist? FTL and causal. That feels like a direct contradiction.
And that's where the key conceptual shift happens. It's all about frames of reference.
Okay.
The basic idea is that speed, it's meaningless unless you say what you're measuring it relative to. CCTV argues it's perfectly lawful to be faster than light relative to the background, the ambient light field, while staying totally causal relative to the underlying structure of spacetime, the light cones.
Okay, let's unpack that. You called the section the frame, not the cheat. So the claim is FTL relative to ambient light, but still following the deeper rules.
Exactly. Think about the light you normally see, just traveling through empty space. Its speed is limited by the geometry of the spacetime it's in.
Okay.
But the pattern described in CCTV, near the horizon, it has access to something different. Rearranged quantum vacuum states.
How does that help it go faster?
It uses these zero-point openings. Think of them as temporary shortcuts in the quantum foam. They let the system deposit energy further downstream much quicker than normal light could get there.
So if I'm watching with my standard clock, measuring against regular light speed...
It looks like the energy pattern jumped ahead. It appears superluminal. It's a fast event, a fast pattern propagation.
Right, but you're saying the fundamental rules haven't been broken, the ones that prevent sending messages back in time.
Correct. The actual causal structure, the thing that dictates cause and effect, what physicists call the principal symbol of the wave operator, that remains absolutely untouched. The light cones are intact.
But couldn't someone, isn't there a risk that someone clever could figure out how to encode a signal onto that fast pattern? That seems like the loophole, the danger to causality.
That's the absolute critical point, and the theory is very strict here. The metric fixes the causal structure. You can observe the pattern moving quickly, yes, but the maximum speed for sending controllable information, a structured message, not just amplified noise, that speed is still locked to the speed of light defined by the metric.
So the pattern is fast, but you can't actually use it to signal faster than light.
The signaling capacity is honest. That's the key.
Okay, that distinction helps. Now, let's zoom in on the black hole itself. This is the tachyonic venting part. The horizon isn't launching things out faster than light.
No, it's not a catapult. Think of it more as a lawful amplifier, a gain stage.
How does that work?
Well, the intense gravity near the horizon causes extreme time dilation. This creates very specific conditions where certain quantum field modes get amplified in time.
Amplified in time, that's what tachyonic means here.
Exactly. In this context, tachyonic doesn't mean moving faster than light through space. It means the effective mass term for these modes flips its sign in that region. And when that happens, tiny disturbances don't just oscillate, they grow exponentially in time.
You used an analogy before, microphone feedback.
Perfect analogy. Hold a mic too close to a speaker, you get that screeching sound. It gets louder and louder, right?
It swells.
That's because the sound loops back through the amplifier, getting boosted each time. But, and this is key, no part of that sound is actually traveling faster than the speed of sound in air.
Ah, okay. The loudness grows rapidly, but the speed is normal.
Precisely. The growth is temporal. The black hole horizon acts like that amplifier circuit, but for quantum fields. It uses a process called SU-101 Bogoliubov mixing to create correlated pairs and amplify them.
So the black hole is like a quantum machine that lawfully amplifies possibilities, which brings us to how the actual radiation, the Hawking radiation, is produced. You described it as a loop, pump, filter, light.
Yes, a three-part cascade.
Yeah.
Stage 1 is the pump. That's the amplification region we just discussed, right near the horizon. It takes quantum fluctuations and boosts them, but it also imprints a specific structure onto them, correlations in phase and amplitude.
And this imprinting leaves fingerprints, measurable signs.
Two crucial ones. These make the theory testable, falsifiable. The first is mass-ordered ignition.
Meaning?
Different particles have different masses, right? Think of mass as stiffness. It takes more energy to excite a heavier particle. So the pump doesn't just turn everything on at once. Lighter particles, needing less of a push, should start venting, radiating first. Then heavier ones follow in order.
So if we saw, say, heavy particles radiating before light ones.
The theory's in trouble immediately. It predicts a specific, checkable sequence.
Okay, that's fingerprint one. What's the second?
The second is a phase ripple. Because the pump region isn't infinitely thin, it has a certain sort of optical thickness. This imprints a subtle, regular timing pattern of phase modulation onto the amplified signal.
Like a watermark.
Sort of, yeah. A timing watermark. And the prediction is that this subtle ripple survives the journey outwards.
Okay, so these amplified, structured ripples come out of the pump region and then hit stage 2, the filter, the exterior Casimir filter. Why is the space outside the black hole a filter?
Well, quantum mechanics tells us that boundaries affect quantum fields. The space outside the black hole acts like a leaky cavity, an output coupler. The static Casimir effect, just the presence of these boundary conditions, shapes the allowed quantum states, the density of states.
You compared it to guitar frets earlier.
Exactly. The frets determine which notes can resonate clearly. The Casimir effect here favors certain frequencies, creating predictable, evenly spaced peaks in the spectrum of the outgoing radiation, like teeth on a comb, spectral comb teeth.
Ah, okay. So the pump creates the signal structure, the filter selects which parts get out.
Right. But the filter does more. There's the dynamical Casimir effect. This is critical for balancing the energy books. If the effector boundary is sort of jiggling or modulating because of the fields interacting with it.
Like pushing a swing.
Yeah, good analogy. That motion, that work done on the boundary, gets converted directly into radiated energy. It's a mechanism for energy conversion, and it has to balance out.
Which leads to stage 3, the light, the actual radiation we might detect. It looks mostly thermal, like a warm hiss.
Almost. It's near thermal. But hidden inside that hiss are the fingerprints, the phase ripples from the pump stage, and the spectral comb teeth from the filter stage.
Structure disguised as noise.
Exactly.
Okay, this feels like the perfect time to talk about closing the ledgers. Conservation laws are everything in physics. Energy, information, it has to add up. You mentioned past models sometimes needed narrative crutches to make the energy balance. CCTV claims 3 levels of rigorous accounting. Why 3?
Because you need to prove it at every scale.
Yeah.
Microscopic interactions, the local boundary physics, and the whole space-time picture globally. It's about nested consistency. No loopholes allowed.
All right, let's start small. Ledger 1, microscopic.
This happens right at the pump with that SUA1 Bogoliubov mixing.
Okay.
It's basically an algebraic rule enforced by the quantum mechanics of pair creation. For every particle amplified outwards, there's a correlated partner accounted for, often falling inwards or remaining virtual. It boils down to a simple identity. Alpha squared minus beta squared equals 1.
What do you mean?
It's the quantum version of what goes in minus what goes out equals what's stored or correlated.
Yeah.
It guarantees no energy is created or destroyed during the amplification process itself.
Okay, that seals the local process. Now, ledger 2, the boundary.
This is the dynamical Casimir power balance we just touched on.
Yeah.
This one is really important because it's potentially measurable, even in lab analogs. It says, on average, the work done on the effective boundary by the quantum fields must exactly equal the power radiated away.
Work in equals power out.
Precisely. If you measure those two things, maybe in an analog gravity experiment, and they don't match up consistently,
Then the theory's broken.
instantly, it's a direct physical check on the energy flow across the boundary.
Very concrete. Okay, finally, ledger 3, global. The slab identity. This sounds the most abstract.
Uses some heavier math, integrating conserved currents, but the concept is straightforward. Imagine drawing a huge box around the black hole in space-time. Ledger 3 says that if you account for all the energy flowing out to infinity, plus all the energy flowing into the horizon, which counts as negative outflow, plus any energy exchange to that Casimir boundary region.
It all has to sum to zero.
Exactly. It proves that overall, across the entire relevant region of space-time, energy is perfectly conserved. The whole system is honest.
Wow. Okay, that three-level accounting, micro, boundary, global sounds incredibly thorough, which brings us to the final massive piece, information. If the radiation is just this near-thermal hiss, how does it carry the information about what fell into the black hole? How does it solve the paradox?
Ah, yes, the thermal deception. It looks like featureless heat if you measure it crudely. Imagine trying to understand a complex piece of music using only a VU meter, just measuring the overall loudness.
It would just look like noise, fluctuations in volume.
Exactly. You'd lose all the melody, the harmony, the rhythm. The information is in the relationships, the timing, the structure.
So the information isn't lost, it's just encoded differently.
Precisely. It's not in the loudness of any single frequency. It lives in the phases, the timing relationships we talked about, those phase ripples from the pump and then the cross-mode coherences.
Meaning how different frequencies, different colors of light are correlated, how they wiggle together.
Yes. That complex web of correlations imprinted by the pump and preserved through the filter carries the information. The exterior region, the filter, acts as what's called a Gaussian CPTP channel in quantum information theory.
Which means
CPTP stands for completely positive, trace preserving. Basically, it's a lawful quantum channel. It can't invent information out of nowhere, but it can transmit existing correlations and quantum states faithfully. It doesn't destroy the phase information.
so the information survives because it was encoded in a way that this specific channel naturally preserves.
That's the argument. The structure imprinted by the pump is exactly the kind of structure that makes it through the Casimir readout channel.
But decoding it, that sounds incredibly difficult. We can't just use a simple telescope detector.
No, absolutely not. That's the challenge and also the prediction. To recover the information, you'd need phase-sensitive, multi-mode measurements. You need detectors that can precisely measure the timing and the correlations between different parts of the signal, not just how much energy is arriving.
So the information paradox is solved not because the information disappears, but because it's hidden in this really complex, high-dimensional structure that we haven't been able to properly measure yet.
That's the essence of it. Information isn't destroyed, it's just stored very, very subtly.
Okay, let's wrap up by focusing on testability. This whole framework is only good science if we can potentially prove it wrong. You mentioned mass-ordered ignition. What else could falsify CCTV?
Well, there are a few clear failure points. One, as we discussed, is that dynamical Casimir power balance. If lab experiments consistently show work done doesn't equal power radiated, that's a major problem.
Right, Ledger 2 failed.
Exactly. Two, seeing particles ignite out of mass order, as you said, that points to the pump mechanism being wrong. And three, the absolute deal breaker. If anyone could ever demonstrate genuine supraluminal signaling.
Sending an actual message faster than light, not just watching a pattern move fast.
Correct. If that happened, it would violate the core principles of causality that CCTV explicitly preserves.
So the final thought for you, our listener, is pretty exciting. We might not need to wait decades for a super powerful space telescope to start testing these ideas about black hole physics and information.
That really is the beauty here. The core physics, the tachyonic pump idea, the Casimir filtering, the nodal conservation laws, these aren't just about black holes. They can potentially be recreated and tested in the lab.
Using what?
Using analog gravity systems. Things like ultra-cold atoms, Bose-Einstein condensates, or special superconducting circuits. You can set up conditions in these systems that mathematically mimic the physics near a black hole horizon.
So you can build a kind of tabletop black hole analog?
In a sense, yes. You can simulate the key effects, and crucially, in the lab, you have control.
You can turn the knobs.
Exactly. You can adjust the pump strength, change the cavity properties, and then directly measure the output. You can look for that mass ordering, search for the phase ripples, perform the energy balance checks for Ledger 2. You can test the predictions step by step.
That's incredible. So the conclusion really is, a black hole might just be a lawful quantum machine, turning amplified possibilities into structured light. And we might be able to prove, or disprove, that by carefully building and listening to analogs right here on Earth.
It suggests these secrets aren't always in the loudest bang, but maybe in the quietest whisper, if you know how to listen to the phases.
A fascinating place to leave it. Thank you for joining us for the deep dive.